When executing Java code, different errors can occur. Coding errors made by the programmer, errors due to wrong input, or other unforeseeable things. So when an error occurs, Java will normally stop and generate an error message. The technical term for this is Java will throw an exception. All exception classes are subtypes of the java.len.exception class. The exception class is a subclass of the throwable class. Other than the exception class, there is another subclass called error, which is derived from the throwable class. Errors are abnormal conditions that happen in case of server failures. These are not handled by the Java programs. Errors are generated to indicate errors generated by the runtime environment. For example, JVM, Java Virtual Machine, is out of memory. Normally, programs cannot recover from errors. The exception class has two main subclasses, I/O exception class and the runtime exception class. An error indicates serious problems that a reasonable application shouldn't try to catch, while an exception indicates conditions that a reasonable application might want to catch. The figure shows a class named division that contains a single small main method, and this method declares 3 integers, prompt the user for values for 2 of them, and calculate the value of the third integer by dividing the first 2 values. And we can see the output shows 2 typical execution of the division program. In the first execution, the user enters 2 usable values, and the program executes normally. In the second execution, the user enters 0 as the value for the dominator, and an exception message is displayed. Java doesn't allow the integer division by 0, but floating point division by 0 is allowed. The result is displayed as an infinity. So in the second execution, most programmers would say that the program experienced a crash, meaning that it ended prematurely with an error. From the display, we can see that the exception is a java.len.arithmetic exception. Arithmetic exception is one of the many subclasses of exception. The output shows some information about the error, the method that generates the error, and the file, and the line number for the error. For example, it's a division.java line 12. We don't use exception handling technique. For example, in this division 2 program, it displays a message to the user when 0 is entered for a denominator value, but it is not able to recover when non-integer data such as a string or floating point value is entered. Object-oriented exception handling enables such error recovery. Programs that can handle exceptions appropriately are said to be more fault-tolerant and robust. Fault-tolerant applications are designed so that they continue to operate, possibly at a reduced level when some part of the system fails. Robustness represents the degree to which a system is resilient to stress and able to continue functioning. The try statement allows you to define a block of code to be tested for errors while it is being executed. The catch statement allows you to define a block of code to be executed if an error occurs in the try block. You create a catch block by typing the following elements: the keyword catch, followed by a pair of parentheses. Between the parentheses, an exception type and an identifier for an instance. A pair of curly braces that contain statements that take the actions you want to use to handle the error condition. The try and catch keywords come in pairs. This figure shows division mistake caught program that improves on the division class. The main method in the class contains a try block with code that attempts division. When illegal integer division is attempted, an arithmetic exception is created automatically and then the catch block executes. When the user enters a valid denominator, the catch block is bypassed. The try block is executed. While when the user enters 0 for the denominator, the try block is abandoned without displaying the division result, and the catch block executes, displaying the error message. So whether the denominator is valid or not, the end of a program message is displayed. You can use the getMessage method that arithmetic exception inherits from the throwable class to retrieve Java's built-in message about an exception. For example, this figure shows a division mistake called to class that used the getMessage to generate the message that comes with the called arithmetic exception argument to the catch block. From the output, the message is slash by 0, that means division by 0. We have learned to add a next line call after any next integer or next double call to absorb the enter key remaining in the input buffer before subsequent input. So when you attempt to convert numerical data in a try block and the effort is followed by another attempt conversion, you also must remember to account for the potential remaining characters left in the input buffer. For example, this program shows that accepts and displays an array of 6 integers. The try and the catch block is to prevent user data entry errors. So if the user enters in invalid data, the exception will be thrown. The message will display the exception occurred. So it's a for loop. The line input.nextLine is also required to absorb the enter key remaining in the input buffer. You can include any legal Java statements in a try block or catch block, including variable declarations. However, you must remember that a variable declared within a block is local to that block. In other words, the variable goes out of scope when the try or catch block ends. So any variable declared within one of the blocks should serve only a temporary purpose. If you want to use a variable both with a try and a catch block and afterward, then you must declare the variable before the try block begins. However, if you declare a variable before a try block but wait to assign its initial usable value within the try-catch block, you must be careful that the variable receives a useful value. Otherwise, when you use the variable after the try-catch pair ends, the program will not compile. See the compilation error in the output window. In this program, X is declared and its value is received from the user in a try block. Because the user might not enter an integer, the conversion to an integer might fail. So an exception might be thrown. In this example, the catch block only displays a message and doesn't assign a useful value to X. So when the program attempts to display X after the try block, an error message is generated. So you have 3 easy options for fixing this error. You can assign a value to X before the try block starts. Or you can assign a usable value to X within the catch block. Or you can move the last line system.out.println X is, then X. So move this line into the try block. If the input is invalid, the try block will be abandoned. So this line will not be executed and there will be no error. So I suggest you use the first option or second option. You can either assign a value before a try block starts, or you can assign a usable value to X within the catch block. You can place as many statements as you need within a try block, and you can catch as many exceptions as you want. If you try more than one statement Only the first error generating statement throws an exception. As soon as the exception occurs, the logic transfers to the catch block, which leaves the rest of the statements in the try block unexecuted. When a program contains multiple catch blocks, they are examined in sequence until a match is found for the type of exception that occurred. Then the matching catch block executes, and each remaining catch block is bypassed. In this program, it throws two types of exception objects. An arithmetic exception, which is for the divide by zero error, and an input mismatch exception, which is it asks the user to input the integer, so if the user inputted something else like a double or character, it will throw the input mismatch exception. For the two catch, one is receiving the arithmetic exception object mistake. The other one is receiving an input mismatch exception object. We can have a catch-all block, which accepts a more generic exception argument, catch exception E. In the previous program, each of the two catch blocks displays a unique message. Here we can use just one catch block. It's a more generic catch block and it can catch any type of exception object because the arithmetic exceptions and the input mismatch exceptions are both subclasses of exception class. In this program, when the exception occurs, the message operation unsuccessful will be displayed. Java finally block is a block that is used to execute important code such as a closing connection, stream, etc. Java finally block is always executed whether exception is handled or not. So Java finally block follows try or catch block. The finally block in Java can be used to put clean up code such as a closing file, closing connection, etc. The finally block executes no matter what outcome of the try block occurs. No matter the try ends normally or the catch executes or the exception causes the method to abandon prematurely, the finally block will be always executed. If you don't have finally, the statements after try-catch block may not be always executed. Now that you know what exceptions are and how to use them, it's time to learn the advantage of using exceptions in your program, separating error handling code from regular code. Exception provide the means to separate the details of what to do when something out of ordinary happens from the main logic of a program. In traditional program, error detection, reporting, and handling often lead to confusing code. For example, this figure represents a pseudocode for traditional error checking. So it passed 3 tests before the final result can be displayed. The program executes method A. It then calls method B only if method A is successful. Similarly, method C executes only when method A and method B are successful. When any method fails, the program sets an error code to A, B, C. Compare the same program logic using Java's object-oriented error handling technique shown in this figure. Using the try-catch object-oriented technique provides the same results as the previous slide, the traditional method, but the statements of the program that do the real works, like calling method A, B, and C and displaying the final result, are placed together where their logic is easy to follow. The try steps usually work without generating errors. After all, the errors are exceptions. It is convenient to see these business-as-usual steps in one location. The unusual exceptional events are grouped and moved out of the way of the primary action. The throw keyword in Java is used to explicitly throw an exception from a method or any block of code. We can throw either checked or unchecked exception. The checked exception means The exceptions are checked at the compile time. If some code within a method threw a checked exception, then the method must either handle the exception or it must specify the exception using throws keyword. The unchecked exceptions are the exceptions that are not checked at the compile time. In C++, all exceptions are unchecked, though it is not forced by the compiler to either handle or specify the exception. It is up to the programmers to be civilized and specify or catch the exceptions. In Java, exceptions under error and the runtime exception classes are unchecked exceptions. Everything else under throwable is checked. The throws keyword indicates what exception type may be thrown by a method. There are many exception types available in Java, like arithmetic exception, class not found exception, array index out of bounds exception, security exception, etc. In this example, the display price method accepts a parameter to use at the array subscript. But because the subscript could be out of bounds, the method contains a throws clause, acknowledging it could throw an exception. Another advantage of exceptions is the ability to propagate error reporting up to the core stack of methods. What's a Java stack trace? A stack trace, also called a stack backtrace, is a list of stack frames. These frames represent a moment during an application's execution. A stack frame is information about a method or function that your code called. So the Java stack trace is a list of frames that starts at the current method and extend to when the program started. Let's take a look at a Java program. So this class calls 4 methods and prints a stack trace to the console from the last one. So when you run the class, you'll see something like the java.len.exception stack trace at java.base/java.len thread stack, etc. So the D method is at the top of the stack because that's where the app generated the trace. The main method is at the bottom because that's where the program started. When the program started, the Java runtime executes the main method. Main called A method, A called B method, and the B called C method, and the C method called the D method. So finally, D method called stack, which generate the output. This Java stack trace gives us a picture of what the program did in the order that it did it. A Java stack trace is a snapshot of a moment in time. You can see where your application was and how it got there. That's valuable insight that you can use a few different ways. Stack traces and exceptions are often associated with each other. When you see a Java application throw an exception, you usually see a stack trace logged with it. This is because of how exceptions work. So when Java code throws an exception, the runtime looks up the stack for a method that has a handler that can process it. If it finds one, it passes the exception to it. If it doesn't, the program terminates. So exceptions and a callback are linked directly. Understanding this relationship will help you figure out why your code threw an exception. Java has many built-in exception classes, such as the no pointer exception and the illegal argument exception. At times, however, you may want to create your own exception class. For example, as opposed to throwing illegal argument exception when a 0 is detected as a divisor during a division operation, you may want to throw a divide by 0 exception. So this exception class doesn't exist in the Java core, but you can create one yourself. In the high balance exception class, a constructor contains a single statement that passes a description of error to the parent exception constructor. So this string will be retrieved if you call the getMessage method with a high balance exception object. So to write our own exception classes, we have a public class and the exception class name. Then we use the keywords extend the exception class. In the constructor, we pass a description of an error to the parent exception constructor. In the second figure, a customer account is constructed in a try block. If the attempt is successful, so if the customer account constructor doesn't throw an exception, the customer account information is displayed in a dialog box. However, if the customer account constructor does throw a high balance exception, the catch block receives it and display a message. Assertion is a statement in Java. It can be used to test your assumptions about the program. While executing assertion, it is believed to be true. If it fails, Java Virtual Machine will throw an error named assertion error. It is mainly used for testing purpose. So assertion provides an effective way to detect and correct programming errors. The syntax of using assertion can have two ways. The first way is a assert expression semicolon. The second way is a assert expression 1 colon expression 2 semicolon. By default, assertions are disabled. The syntax for enabling assertion statement in Java source code is java-ea, then you put the class name. To enable assert in NetBeans, first of all, you right-click on the project in the Project Explorer window. Then you choose Properties at the bottom of pop-up menu. Then you choose Run and the category. Then you set the VM options field to include -enable assertions. Then click OK. In this program, the method is even method. Its assert statement has been added. The statement asserts that when the remainder of a number divided by 2 is not 1, it must be 0. If the expression is not true, a message is created using the value of both number and its remainder after dividing by 2. For example, -5 modulo 2. The result is not 1, so -5 doesn't belong to odd here. That doesn't mean -5 is even. So in this assertion, the -5 modulo 2 doesn't equal 0. So the message after the colon in the assert statement will be displayed. When the even-odd program executes and the user enters -5, the program displays the message. As in the output window, you can see the message that assertion error was thrown and that the value of -5 modulo 2 is -1 is displayed. A virtual keyboard is a computer keyboard that appears on the screen. A user operates it by using a mouse to point to and click keys. If the computer has a touch screen, the user also can touch keys with a finger. So you can use the code similar to that shown in this figure to bring up the virtual keyboard in Windows operating system. In the try block, every Java application has a single instance of the runtime class that allows the program to interface with its environment. The exec execute method executes the operating system program named osk.exe. So osk.exe, osk stands for on-screen keyboard. The execute method throws an uncaught IO exception, so its statement is contained in a try block. We have used the scanner class for input and output. Now that you understand how exceptions are thrown, you can also use this virtual keyboard. The virtual keyboard appears as soon as the program starts. When the prompt appears at the output window as a command line, the user has the option of typing on the standard keyboard or using the on-screen version.